This is an example of how we can use the decibel system for expressing the loudness of a sound. The problem states that a firework rises 210 meters into the sky before it explodes with a sound level of 85 decibels to the people on the ground. And the first thing we're asked is, what is the power of that single explosion? Well, the first thing we always have to do is to write out what we are told. And the two pieces of data we have here is that the firework explodes 210 meters away from us with a decibel level of 85. All right, so we write down that given data right here from the very start, and that's going to be a distance of 210 meters and a decibel level of 85. Right? Now, the two relevant equations for this problem are going to be the decibel equation itself, which states that the decibel level is 10 times the logarithm of the intensity divided by the threshold of hearing. Another important equation is the equation for sound intensity, which is the power output of the sound divided by 4 pi times the distance squared. That will tell us the intensity of the sound, and the threshold of hearing, I naught, is 1 times 10 to the minus 12 watts per square meter. All right, so these are the data that we're given. These are the relevant equations. And in part A, we are asked for the power of the initial explosion. Right, so in part A, we are asked for the power. Right, well, we take this in steps. We begin with the decibel equation, 10 log intensity over the threshold of hearing. That intensity is 85. We now divide both sides by 10, right? That gets us to 8.5 equals the log of the intensity divided by the threshold of hearing. To undo the logarithm, we take 10 to the power of 8.5. That undoes the logarithm and leaves us with the intensity divided by the threshold of hearing. 10 to the power of 8.5 is 3.162 times 10 to the 8th. So we can calculate the intensity of the sound as 3.162 times 10 to the 8th multiplied by 1 times 10 to the minus 12, the threshold of hearing. That gives us an intensity of 0.000316 watts per square meter. Then we look up here and we see the formula for intensity. That's going to be the power divided by 4 pi times the distance squared. Solving this equation for power, we get that power is intensity multiplied by 4 pi times the distance squared. In our case, that means that power is 0.000316 times 4 pi times 210 meters squared. That leads to a power of 175 watts. Since this problem has two significant figures, we would report this as 180 watts. Looking at part B, we're asked if that same firework rises to a height of 520 meters, what is the decibel level of the explosion? Well, in part B, we have new data, a new distance of 520 meters. We keep the same power level, however. It's the same explosion, so it has the same power level of 175 watts. Therefore, we can calculate a new intensity. Intensity is power divided by 4 pi d squared. That's 175 divided by 4 pi times 520 squared. That gives us a new lower intensity of 5.157 times 10 to the minus 5 watts per square meter. We place this into the decibel formula. 10 log times the new intensity, 5.17 times 10 to the minus 5 divided by 1 times 10 to the minus 12. So 5.157 times 10 to the minus 5 divided by 1 times 10 to the minus 12 is 5.157 times 10 to the 7th. The log of that is 7.7, and so the final decibel level is 77 decibels. So this higher explosion has a lower decibel intensity, as we would have expected. Now in part C, we have a grand finale, which occurs at the original height of 210 meters, but instead of one explosion, we now have 7. That means in part C, we take the old power level of 175 and multiply by 7 to get a new power level of 1,225 watts. That's going to lead us to calculate a new intensity, which is power, divided by 4 pi times the distance squared. So we have the new power of 1,225 watts divided by 4 pi times the distance of 210 meters squared. That gives us a new intensity for the explosion of 0.0022 watts per square meter. All right, we then go to continuing part C. We then go to calculate the new decibel level, which is the log of our new intensity, 0.022, divided by the threshold of hearing, 1 times 10 to the minus 12. All right, and that gives us, 0.002 divided by 1 times 10 to the minus 12. Take the logarithm of that, multiply by 10, we get a final answer of 93 decibels. It is louder, as we would expect. No, it's not 7 times louder than the old intensity, right? It's about 8 places larger because, remember, the decibel system is a logarithmic scale, not a linear scale. So yes, the decibel level is higher, but it's not 7 times higher.